In this lesson, we are going to find the common difference for an arithmetic sequence, write a rule for an arithmetic sequence, find the nth term of an arithmetic sequence, and find the sum of an arithmetic series. An arithmetic sequence is a sequence in which the difference between consecutive terms is constant, and a common difference is the constant of difference from our arithmetic sequence. We denote this by D. So taking a look at our examples of arithmetic sequences, our first one says 3, 7, 11 are our first three terms. Noticing from 3 to 7, all we're doing is adding 4. Similarly, from 7 to 11, we're adding 4. So if we continue this pattern on to the next two terms, 11 plus 4 is 15, plus 4 is 19. So our common difference in the first example is going to be equal to 4 because we're just adding 4 every single time. In the second example, notice going from 8 to 3, we're just subtracting 5. Similarly, from 3 to negative 2, we're subtracting 5. So if we find the next two terms, we're going to get negative 7 and negative 12. 12. And our common difference is going to be negative 5. Now let's say we wanted to write a rule for these two examples. An easy way to think about these is to look at our linear equation y equals mx plus b. This is going to be a good way to remember to write our rules. M is going to be our slope in the line, but in this case, it's going to be equal to d, or our common difference, because it's what we're taking times our term every single time. So an equals, remember, our first term is actually 1, and we have to think about what did we do to the first term, 1, to get a 3. So if we use this common difference and we say it's 4n, 4 times 1 is 4, but we can subtract 1 to get a 3. Go back and check, does this apply to each of our terms? Our second term is 7. For our second term, 2, 4 times 2 is 8 minus 1 is 7. So this will in fact work. For our second problem, if we get our common difference of negative 5, we're going to get a negative 5n. And how do we get from negative 5 times 1, which is negative 5, to 8? Well, we add 13. And similarly to the example above, you can go back and check the rest of the terms, and this rule will in fact work. We want to make sure that we can identify arithmetic sequences in this lesson. So this problem says, decide whether or not this sequence is arithmetic. So in the first one, notice from negative 10 to negative 6, we're adding 4, adding 4, adding 2, adding 2, adding 4, adding 4. Our common difference here is not the same between every term, so this is not arithmetic. In the next example, 5 to 11, we have plus 6, plus 6, plus 6, plus 6. Yes, the constant never changes in this sequence, so it is in fact arithmetic. Yes. The next thing we're going to do is write a rule for the nth term of the sequence. So the nth term of an arithmetic sequence with the first term a1 and the common difference d is given by the equation below. A of n equals a1 plus the quantity n minus 1 times d, or the common difference. So from there, we're going to look at the first example. It says the sequence is 32, 47, 62, and 77. The first thing we want to do is find d. So how did we get from 32 to 47? Well, we added 15. How did we get from 47 to 62? Again, we're just adding 15. Since we know what our common difference is, we can start plugging numbers into the equation given above. So, an is equal to a1. a1 is our first term. and that is 32. So an equals 32 plus n minus 1 times d, which we found is 15. From here, it's just simple algebra. We're going to distribute that 15. So we're going to get an equals 32 plus 15n minus 15. Simplifying, we get an equals 15n plus 17. Notice, once again, we have it in the form that we like, y equals mx plus b, m being our d, or common difference, which was 15. Okay, so the second part of this question asks to find A12. So A12 equals, using the equation that we came up with, or the rule, 15 times n. And if we're finding A12, that means our n is equal to 12 plus 17. Once again, simple algebra, simplify, so we get that A12 equals 197. Okay, the next thing we want to take a look at is finding the nth term given a term and the common difference. So the example below states one term of an arithmetic sequence is A8 equals 50, and the common difference is 0.25. Write a rule for the nth term. So I'm going to use the equation that we have been referencing, y equals mx plus b, remembering that our m is our common difference in this case, and our y is our a sub n. So we get a sub n equals 0.25, which is our common difference, times n, plus a number. We are given that A8 equals 50. So if our A8 equals 50, that means AN is 50, which is going to be equal to 0.25 times n, which we know is 8, 0.25 times 8, plus x, because that's the number that we're trying to find here. So if we simplify, we get 50 equals 2 plus x. Solving for x, we find that x equals 48. So the rule for the nth term, if we plug this number back in, is going to be an equals 0.25n plus 48. Now we're going to find the nth term given just two terms. So the question states two terms of an arithmetic sequence are A5 equals 10 and A30 equals 110. Write a rule for the nth term. The way that we like to think about these problems when we're given two terms is going back to our slope, to our equation of our linear form, y equals mx plus b. We want to find d, so how did we find m? Well, we found our slope by using a slope formula. So what we can do is take the two terms that we know and write them in coordinate form. A5 equals 10 and A30 equals 110. Now we have two coordinate points. So if we remember our slope formula, it's our y2 minus y1 all over x2 minus x1. Since we found two coordinate points, we can just plug these values in. So we get 110 minus 10 over 30 minus 5, which is going to give us 100 over 25, which is 4. And if you remember what we were finding in the first place, our slope is our common difference, so d equals 4. From here, we can go back to the equation that we were using previously. An equals 4 times n, because we found our common difference, plus a number. From here, you have two choices. you have A30 equals 110 or A5 equals 10. My personal preference, I like to use the smaller numbers because they're easier to solve in equations. So AN or A5 equals 10, so 10 equals 4 times 5 plus x, because that's the number that we're trying to find for our rule. So we get 10 equals 20 plus x, so we get x equals negative 10, and that's the number that we're going to plug back into our equation for our rule for the nth term. So our equation is AN equals 4n minus 10. Now it asks us to write the value for n for which AN equals negative 2. So we're simply just going to plug in points or plug in values into our equation to find n. So we get negative 2 equals 4n minus 10, 8 equals 4n, n equals 2. Simple algebra. The last topic we want to cover is arithmetic series. The formula for the sum of an arithmetic series is given below. The sum of the first n terms of an arithmetic series is denoted S sub n. And the equation for S sub n equals n times a1, which is our first term, plus an, which is the rule for all terms, divided by 2. So in our first example, it says, consider the arithmetic series 20 plus 18 plus 16 plus 14 plus etc. Find the sum for the first 25 terms. So it says that the sum that they want us to find is for the sum of the first 25 terms. That tells us that our S sub n equals S sub 25. If we plug our numbers in, we know our n equals 25. And then we have our a1, which we can see our first term is 20, plus an. But we don't know what an is, so we have to find that first. Let's find the common difference. Notice we're subtracting 2 from each of our terms, so that's the common difference. So we get that an equals negative 2n plus a number. We can use any one of these terms. I'm going to use the first term to make it easier on us. So we have a1 equals, well, negative 2 times 1 plus x. We know that a1 equals 20, so we get 20 equals negative 2 plus x. So we get that our x equals 22. So our rule for a of n is going to equal negative 2n plus 22. We can use this rule and find out the a sub n that we need for our equation. We know that n is equal to 25, so now we have to find a of 25, which is negative 2 times 25 plus 22. So if we distribute our negative 2, multiply, and then add, we're going to get negative 28 for our a sub n, or our a sub 25. So from here, we can then go back to our equation that we were setting up, plug in negative 28 into the equation, and finish that up, divided by 2. So simplifying, we get S of 25 equals 25 times negative 8 over 2. So we get S of 25 equals negative 100. So it asked us to find the sum of the first 25 terms using the equation. That's just what we did. The sum of the first 25 terms is negative 100. So the next part of our question says, find n such that S of n equals negative 760. Notice that I've run out of room, So I'm going to move this question to the next slide. The information that we need to carry is what our a sub n equation is, or the rule for our nth term. And a little helpful hint is our sum equation, s of n equals n times a1 plus an over 2. So it says find n such that Sn equals negative 760. So that's just what we'll do. We know that S of n equals negative 760. So negative 760 equals n times a1 is still our first term from the previous slide, which is 20, plus an is now just going to be substituting in our formula. So that's negative 2n plus 22 all over 2. Now what we can do is simplify what's inside the parentheses and distribute what's outside the parentheses. So we get that that is equal to n times negative 2n plus 42 over 2. And if we distribute the n into the numerator, we get that negative 760 is equal to negative 2n squared plus 42n. Oops, plus 2n all over 2. I'd really like to get rid of this denominator here without having to multiply it times 760, so we're going to notice that we can take a 2 out of the first term, or a negative 2. So we get, second hand, let's just take out a positive 2. Okay, so we get n squared plus 21n all over 2. We can cancel these 2's out to just leave us with negative n squared plus 21n. So now what we can do is put this into a quadratic equation. I know we dread these types of problems, but we're going to have to face it sometime. So we get negative 760 equals negative n squared plus 21n. Moving these over to the other side, we're going to get n squared minus 21n minus 760 equals 0. We need to factor this equation. If you can't figure out how to factor it, please use the quadratic formula. Luckily for us, I've done it in advance. So we get n plus 19 and n minus 40 equals 0. So our n is equal to negative 19 and positive 40. Notice that we can't have negative amount of terms, so this negative 19 is just not going to work. So our answer is going to be n equals 40. The things that I'd like you to review most from this section are the terms that we went over, which are arithmetic sequence and common difference, and the rules and the formulas that we've set up. We know that one of our rules is a of n equals a1 plus n minus 1 all times d, or the common difference. But I'd also like you to remember our y equals mx plus b formula, or an equals dx plus b. That one really helped us out this time. So then the formula for the sum of the arithmetic series is something that you're also going to want to remember. And that will conclude the lesson.